Welcome back, everyone. I'm continuing on the Denon DRM-800A here. And before I put the door back on, I noticed a little bit of a misalignment, so I thought I'd show that as well as I could quickly. You know, it's a little bit out of focus here, but it's actually kind of difficult to try and focus on a mirror with the little monitor on the camera. Even zoomed in, it's tough, but the next segment's better. So hang on. Anyway, I'm trying to show this little bit of a misalignment on the supply side guide. And I noticed this while I was doing the wound flutter tests. So of course I lined these up a long time ago, but I've had the deck in and out a few dozen times, and this little lock nut they're using isn't doing a whole lot of locking, so it's really possible that I bumped it and moved it. But I caught it, and I've got it realigned now. I never lock these screws down until after I've got the door back on and run through all these checks again. Sometimes it moves a little bit, especially on one like this that has the cassette stabilizer. It can change the position of the shell. Okay, so here's a little bit better focus and not quite so much digital zoom. And obviously I can't see what you're seeing. I'm looking at it from the side. It would have probably been better without the little pen light, but I thought I was helping. Anyway, I've got this tracking well now. I've said this in the past. Those guides are guardrails, not railroad tracks. The tape should track correctly, even without them. Okay, so I'm moving on to my final wound flutter tests here. I've got this working quite well. I'm using the original homemade tape that I've been using all along, and in just a second here I'll put my reference tape in and show you. But what I'm looking for here is again the 5 kilohertz spike. There's a 6.3 kilohertz spike, and that will be the belts, undoubtedly. And here's my traditional reference tape. I'll run it on the back side because the front side is full of dropouts, and this side also has dropouts, but not quite as bad. Just going to try to make sure that it's seated correctly. I'll run the test quickly for you. And you can see I've finally got this thing down into their advertised spec. So I'm happy with that. This was a tricky one because of the belts. And you can see the 5 kilohertz spike is gone. There's a 6.3 fundamental and a 12.5 harmonic. And that's belts. Okay. Let's move on and do a preliminary set on the azimuth. I'll also do this again following the installation of the door. But we'll get it set here and see how much it changes. It wasn't very much, but sometimes there's a little bit. That was the end of that tape. That's the first run on this brand new tape all the way through. So I'm starting on the second run. And I'm obviously cross-checking this with the scope. We'll set the speed. I've got a few hours on this since I first adjusted everything. This has a new motor in it, and the new motor pot is clocked differently than the original one. And the position of this one is actually a little bit better because I can rest the screwdriver on the transformer and just kind of take my time and not have to worry about it dangling out there. So that turned out really well, actually. Yeah, let's try it about right there. And when you see that no data there, that's the dropout. And you can see there's quite a few of them. Okay, just hit the wow and flutter one more time while it's still in here. And yeah, I'm very happy with this. I think 0.38 is the advertised spec on it. So I'm hovering right around that number. I'm going to do a quick frequency sweep on this Type 1 Sony and just see where we're at on that. And I'll speed through this for you so you don't have to suffer through it. This will be monitoring the recorded signal, and then I'll wind it back and measure the playback. You can see there's a little bit of change there. Not much, but there's some on the high end. But nice flat lines, a little bit of level difference. I'll actually dial in the levels on the owner's tape that he sent so we can get that close for him. So even on this Type 1 tape, I'm still getting excellent frequency response. I haven't at this point touched any of the internal controls. This is just as received. Just kind of doing a before and after. You can see it's probably just a little bit under biased here, but that's kind of what they're asking for in the manual as well. Kind of asking for a little rise. But even on a Type 1 tape, you know, out to 27 kilohertz of usable signal. I mean, it's laying down signal. So the alignments are good. And I'm checking the phase, and it is in phase all the way through. Sometimes they're not. I've run into them where they weren't this good. Okay, so this is, I've got the main board, the power supply recapped. Working on the audio board. This is most of my capacitors. And I do crimp these the way the factory does, relieve the stress off those leads. Using sockets, I've already got them in for these replacement 4066 noisemakers, and then a couple of op amps to test with later. I don't have all the capacitors in yet. They should be here in a couple of days. Okay, so here it is done. I have upgraded the signal path to all Nichcon Muse bipolars. Backside all cleaned up. The RCA jacks cleaned up. Now this is my procedure. I've shown this before too. When I remove these caps, I don't do them one at a time. I put them out in a foam like this. Keep them organized just in case later on I have to go back and debug something that I put in wrong. And a couple of times that's saved me. Alright, so at this point I want to do the high frequency erasure test. I've got the bezels all polished up and a protective sheet on them for shipping, and so I don't scratch them. I'll take this one off so you can see it better, but I'll leave the one on the cassette door so I don't scratch that up while I'm working on it. The Sony Type 1 is reportedly the worst offender of this. So I'll do this one first and then move on to some others. This is recording about 20 seconds or so of a 15 kilohertz signal generated by the T100. I'm not worried about levels or anything like that here. This is just a comparator from 10 plays or more against the unplayed signal. So I'll just try to get those as close as I can for you guys to zero. I'm reading it about 1.5 or about a half a dB high. Okay, so there's the first play, and then I'll fast forward through. I didn't count them, but I know I did at least 10, probably closer to 15. And then on the last playback, we'll let it run through those. I actually missed it. It's going to be more like 13 seconds. And then we'll just let it run through the last play into the section that was not played back and see what kind of difference we get there. To make it easy for you guys, I'll put I'll circle around the bar graph just as it hits the 13-second mark. Okay, so there's, I don't know, I lost count. I tried to count them, but I lost count. I know it's at least 10, maybe as much as 15 playbacks. Okay, so look for the ready lips, and that will be right when it hits the 13 mark. Okay, so there's the rise, maybe a dB right in through there of erasure after that many plays. And that's pretty consistent with the last DRM-800 I did for Steve. Okay, this will be the owner's tape that he sent to have the deck optimized for. Do the same test with it. Again, just pretend that's a 0. I'm doing the best I can on the little camera monitor a couple of feet away from me. And what I'm doing here is I'm trying to find a spot on the tape that I didn't already record, but I don't know if I'm being very successful at that. We'll just pick a spot and do the test. Okay, zero it out. Let's do it right here. Okay, so you're seeing it pretty close to 0. I'm seeing it a little bit above 0. Well, you're probably seeing it -1, I guess. Again, I have not gone through the calibrations yet. This is just straight out of the rack. Okay, so that's not good on that first result. I'm down, what, 2-3 dB on the very first playback. So I don't know. I mean, it shouldn't be like that. Let's maybe do it again here, see what happens. Now there is a reason for this, and I show it a little bit later in the video, but right this second it was baffling me. Okay, we'll start again. I've got the levels up a little bit closer to 0 for you. Yeah, again, it doesn't matter. It could be at any point. And that 0 dB is not a reference. If you look on the tape meters, you'll see I'm actually doing this at minus 20 dB. All right, get my memory set again. I forgot to do that. Okay, so this will be the first playback. Obviously, that's a test signal from something else. Okay, I'm not speeding through this because I wanted to show you what I was seeing here, an anomaly. So now the left channel is higher than the recorded signal, which of course is impossible. So now I'm starting to chase yet another problem I've run into on this one. Okay, so now it's down a full dB. So I'll fast forward through this and show you all the weird results I'm getting in those 10 or 15 plays. And then I'll show you what the problem was. See, there you go, just all kinds of different numbers. There you go, higher again, which is impossible. Should be a couple in here that are quite low. You know, I did this multiple times trying to figure out what was wrong, so I'm not sure which clip I included here. Okay, here's playing through right there. So you see about a dB rise on the unplayed section. It actually shouldn't be like this. It should be solid all the way through. Okay, so I've done a bunch of plays back and forth. I've tested several different tapes, including the TDKs, SAs. I've done, I don't know, a D, a TDK-D. This is the only tape that's behaving this way. I'll try to show it again. I've tried both sides, A and B, of this tape. Same problem all the way through. There you go. I think this clip shows some big reductions on one channel. Yeah, so it was like this every time I tried it. Look at that, just odd. You know, what would cause that on this one tape and not the other tapes? And initially I was blaming, and I spoke with the owner, Tom, about this, and I said, I think it might be some maybe oil contamination or something on this tape. One of the capstan oil seals was cracked on this, and I thought maybe some oil leaked out and contaminated this tape. Yeah, look at that. What's going to cause that? This is the only tape that did it. Okay, so just completely random results back. Obviously not the machine. The only tape that does it. And he's got, he said quite a few of these tapes that he wants to record on. And so I really want to try to get this sorted for him. And if it is a problem with the tape, then he needs to be aware that there's something going on. Okay, I'll just fast forward through the rest of this one, but you can see, there you go. You can see what I've been seeing here. It's all over the place. So just to show you another XL2, just one of my own here. Similar, not exact, different eras. And this one's got some music on it, but that's okay. Again, I'm not going to worry about levels or anything like that. I'm just going to run it straight where it is and make the test. I'll fast forward through all this. Now again, this goes back to a comment on one of my videos that a viewer made me aware of this issue. I was not aware of it before. This high frequency erasure on type 1 tapes, on these wide gap ferrite erase heads. And so in a previous video, or maybe several of them, you might have seen me lapping that and then coating it with a graphene impregnated ceramic marine coating in order to eliminate that, and it's been successful. I've done, I don't know how many, maybe 4 or 5 at this point, and they've all been pretty successful at eliminating that. And what I'm hoping is the ones I've done, the owners will report back after about a year, maybe take a minute and do the test and report back and let me know how long this coating is lasting and protecting those heads from pitting. Okay, so again, no count. I'm just, I'm trying to count, but I lose track. I know there's at least 10 or 12. There's probably more than that. Okay, so you can see no weirdness on this Maxell. It's pretty consistent every playback. Okay, coming up here, I'll put the mark or the ellipse up at the 10 mark. You can watch that. You can see no discernible reduction in amplitude on either one of those channels. And that's how it should be. Okay, so that's that one. And that's the one that's got the problem. So what I want to show you here is what I found. after scratching my head a few times. Try to get it in the focus plane for you. That pad right there is wiggling around like an old hen's tooth. That's what's causing the problem. At this point, I've already stretched that out a little bit so that it's, you know, convex against the tape instead of concave. Here's just a random TDK, you know, absolutely solid in there. And there's the bad one. All right, so let's take care of this. Like I say, I already bent that spring back so it was in contact with the tape. It was way convex in the first place, in addition to wiggling. So I already bent that back a little bit, and now I just need to keep it from wiggling around so much to and fro. And I think the way I'll do that, I want to look here, but I think the way I'll do that is to just bend those tabs in a little bit. More or less reduce the length of it. Why this happens, I have no clue. But there you go, there's how much. I think I'll just use these tweezers and my hand and just give those a little bend and keep it from wiggling around so much. Just trying to get you a good view here of how much play there is in that back and forth, left and right, fore and aft, whatever. See, it's just, that's the problem. I also did clean this pad. I blew it out with compressed air while I had it out, and it was quite dirty, quite contaminated. Yeah, do my best here to show you how I bent that back. Just grab the tab and just give it just a little tiny bit of a bend, just like that. Let's see if that helped any. Should. I'm definitely calling that better. Put them back together and give them another test. Yeah, I think that's helpful. Okay, let's do it again. And just give it a little bit of recording time here and then reset it to 0 so you don't have to listen to anything else. Try to get it up to 0. Yeah, it looks close to me. Okay, we'll do it from right here. I'll fast forward through all of it. You'll see no weirdness. Left channel looks a little high, but again, I'm not calibrated yet. Okay, none of that previous weirdness. So that whole production was just for that little loose pad in there. Okay, coming up on the run through. Okay, there it is. No change. And that's how it should be. That was it. One other little thing I noticed here that I wanted to show when I was putting the faceplate back on is this ground lug is connected to the faceplate anodizing. Anodizing is an insulator, and so whatever they were intending for this to do, it's not doing. There's absolutely no continuity between that lug and the faceplate. Let me just show you here, in case you don't believe me. There's the lug, there's the faceplate. Nothing there. Okay, there's no continuity there. So I'm going to take care of that quickly. These are known to have some isolation problems, and not just these, a lot of them have that. So whatever this was for, it's not doing its job. Now normally I would use something like this, a piloted brush, but that's too big obviously for that little screw. So my plan is to just try a wire brush on a Dremel. Just mask this off. Try to get a nice circular spot to mount that back with. Now, one of the problems is this faceplate is grounded in other spots, but this screw goes right into a plastic bracket, and engineers don't put grounds like this unless they need them, and this wasn't doing anything. And so just to my mind, the difference in ground potential is unhelpful. So that super fine brush on the Dremel isn't cutting through the anodizing at all. It's not even touching it really. So I'll go find something else to do this with. Alright, I'm going to try these little die makers files. I know this isn't the best use of them. The anodizing is going to dull them up, but I'm not doing that much with them, so hopefully it won't hurt them too much. Got a couple of different ones here I'll try. And just clean it up with the Dremel. It does that job okay. Blow it off. Yeah, that should do what I need. I'll put a little bit of dielectric on this, prevent the oxidation of the aluminum. This particular deck, I usually put dielectric on all the ground screws and lugs, clean them and everything. This particular one already had dielectric on all the ground screws, which was nice. I don't generally see that. It's something kind of I do just behind the scenes on all of them. I usually polish up any of the contact surfaces and then put this keg dielectric on it. Of course, I know it's making contact. I just want to show the camera. Just find a spot in here where the screw has worn off the anodizing. There you go. Now that's a steel bracket in there, so again, this is screwed into a plastic bracket. Okay, so I'm going to get some runtime on this deck. I'll probably do 1 or 2 more videos on it when it's finalized, but as it sits right now, it's got cleaned up just absolutely beautiful. This deck looks like it just came out of the box. The couple of marks I didn't think I could get out did come out, and it just really looks beautiful. So that's it for this one. Thanks again for watching, and stay tuned for the next one.